Assalamu alaikum dear students. So today we are going to talk about parathyroid gland parathyroid hormone. We will also discuss regulation of calcium ion and phosphate ion. So parathyroid hormone, there are three hormones and three systems that play a role in controlling calcium level in the body. So there are three hormones and three glands that play a role in the controlling calcium level in the body. Also phosphate level is also controlled with the level of calcium. So there are three systems and three hormones that control the level of calcium, and these systems include kidney, it also include GIT, and it also include bone. These are the three systems that control calcium level in the body. Hormones that are playing a role in control of calcium level. These hormones include calcitonin, parathyroid hormone, we will simply write PTH, and another is vitamin D active form. So vitamin D is also acting as a hormone, and it acts on the proximal convoluted tubule. It is activated in the proximal convoluted tubule. It is activated in the proximal convoluted of the nephron of the kidney, and it acts on the GIT. We will discuss mechanism of action of vitamin D. So these are the three systems and three hormones that are playing a role in calcium regulation. Now I am going to discuss calcium in blood. Calcium in blood. What does it mean? It means that in which form calcium is present in the blood. So calcium exists in two forms in the blood, mainly two forms. We will discuss its types then. So calcium exists in the blood in the two forms. One is ultra filtrable, and other is plasma bonded. These are the two main types of the calcium that are present in the blood. So plasma bonded and ultra filtrable. Ultra filtrable mean it can be filtered. It can be filtered, and this is again in the two form. What is mean by plasma bonded? This is unable to filter. Unable to filter, and it is present 40% of all calcium. Okay, what does it ultra filtrable mean? It can be filterable, and this exists again in two form. One is bonded with anion bonded, and other is free. This is again free calcium. I write is in this form, double positive. So anion bonded is a what type of calcium? This is bonded with anion. What is mean by anion? Anions are a negatively charged molecule. For example, these anions include phosphate, including phosphates, SO4 negative minus 2 sulfates, etc. And this make 10%. Okay, so in this form, anion bonded calcium, it is bonded either with phosphate, making calcium phosphate. It is bonded with sulfate, making calcium sulfate, and this form 10% of all the calcium in the blood. This form is a free calcium ion. This is that calcium ion that perform different function in the body, and this is making 50% of all the calcium, making 50% of all calcium in the blood, and this is that calcium that perform different function in the body. So this is the presence of calcium in the blood. Calcium exists as a ultrafiltrable that can be filtered and plasma bounded, unable to filter and making 40% of all calcium. Now ultrafiltrable again is existing in two forms. One is anion bounded, that calcium which is bonded with phosphates, sulfates, making 10% of all the calcium, and the other form is free calcium ion, is the main calcium that is perform the function in the body, and it is mostly abundant, and this is for making 50% of all the calcium. Now let's talk about parathyroid hormone PTH. So PTH maintain calcium level in the blood. What does maintain mean? PTH increase calcium level in blood. This is the most important sentence in this topic of parathyroid hormone. Parathyroid hormone increase calcium level in the blood. So parathyroid hormone is secreted by chief cells of parathyroid gland. Chief cell produce and store parathyroid hormone. Whenever there is a low level of calcium in the blood, parathyroid hormone is secreted. Low level of calcium activate chief cell which have 7-pass receptor for calcium ion. Then parathyroid hormone is secreted into the blood, and parathyroid hormone then perform different activities, and as a result of all these activities, calcium level increase in the blood. Now let's talk about activities of parathyroid hormone. So let's talk about working of PTH. So when calcium level in the blood decreases, calcium level decreases in blood, then parathyroid hormone increases in blood. This parathyroid hormone perform different activities which include number 1, bone resorption and removal of calcium, we can say in this way, from bone to blood. This is one function that parathyroid hormone perform. It remove calcium ion from bone to blood. Number 2 function that is performed by parathyroid hormone is reabsorption in kidney. From nephron tubule, calcium ion is reabsorbed into the blood, peritubular capillaries, and level of calcium ion is increased in the blood. Number 3, reabsorption in gastrointestinal tract, and this is performed by vitamin D. Reabsorption in the GIT. So the main function of parathyroid hormone is on the 3 organs that we discuss, that I told about at the start of the lecture. Parathyroid hormone acting on the bone, parathyroid hormone acting on the kidney, and PTH acting on the GIT, and this is mainly due to vitamin D. So these are the different functions of parathyroid hormone. Now we will discuss mechanism of all these functions one by one. Now let's discuss about calcium ion reabsorption from bone. Action on bone. Action of PTH on bone. So in the bone, calcium exists in 2 forms. One that is easily removed. Easily removable calcium. and one that is not easily removable. So first of all, discuss about the calcium that can be easily removed. This calcium is easily removed by PTH because this is only bonded with phosphate in the bone. So this calcium is bonded with phosphate in the bone, and thus PTH act on the bone and remove calcium ion from the bone. The second form is not easily removable. What actually happen in this case? In this case, calcium is bonded with the phosphate, bonded with phosphate, collagen type 1. In bone we know that type 1 collagen is present. Collagen type 1, phosphate, collagen type 1 and hydroxyproline. So all these molecules are present at the same time. When parathyroid hormone act on the bone at this structure, it is very difficult for parathyroid hormone to remove calcium ion from these structures. So these are present in this form. For example, this is collagen type 1, and this type 1 collagen, all the molecule phosphate, hydroxyproline and calcium ion are present. For example, this is hydroxyproline, this is calcium ion, okay, and this is phosphate, and this is collagen type 1, hydroxyproline, phosphate, calcium ion and collagen type 1. These are present in this form at different places, okay. At different points all these structures are present. So first of all, in this case, PTH activate osteoblasts. Osteoblasts then activate osteoclasts, and osteoclasts then come here and produce certain enzymes. This is osteoclast. This produce enzymes that break collagen and at different points, and thus all the molecules are separated in the bone. Collagen is broken at different points. It become like this. It is broken at different points. Phosphate and calcium. All these molecules go to blood from bone. Thus in the bone what will actually happen, not in the bone, in the blood, what actually will happen is that in blood calcium ion concentration increase, phosphate concentration increase, and hydroxyproline concentration also increase. Hydroxyproline concentration is increased, and this hydroxyproline go out of the body through the urine. So when we do test for hydroxyproline of the urine, we find that in the urine there is high concentration of hydroxyproline, then it indicates that anywhere there is bone reabsorption, and it indicates that parathyroid hormone is high in the body. Now the most important point to be noted that the bone synthesis occur in alkaline medium. Bone synthesis with respect to calcium, we can say that anywhere in any organ calcium accumulation occurs in alkaline medium. This is the most important point to be noted. Bone synthesis in what will happen in the bone synthesis. Calcium ion accumulation occur in the bone or in any other organ. For example, we will discuss in the lungs, etc. in the kidney. Calcium accumulation will occur in all the points, all the places where there is alkaline medium. Okay, so opposite to that is calcium ion removal. General word to be used is calcium removal occurs in acidic medium. Okay, so anywhere when there is acidic medium, removal of calcium will occur. Now another point, total calcium level in blood, normal. What is the normal calcium level in the blood? So this we will write here in different units. For example, if we measure it in a millimole per liter, it will make a 2.5 millimole per liter. 2.5 millimole per liter or 5 milli equivalent per liter. This is another unit, or we will say 10 milligram per liter. This is in unit, and we will use this most of the times. Okay, now we know that phosphate and calcium ion are separated in the kidney by Pth. We know that in the blood calcium and phosphate are present at same time at the same place together, but we want to increase free ion, calcium ion in the blood. For this purpose we have parathyroid hormone, and this parathyroid hormone separate calcium and phosphate in the kidney. So what actually happen that calcium ion Pth increase calcium reabsorption in the kidney. Pth increase calcium ion reabsorption in kidney. Okay, and inhibit, negative mean inhibit phosphate reabsorption in kidney. What actually happen? Calcium reabsorption in the kidney occur in distal convoluted tubule, and inhibition of and phosphate reabsorption in the kidney occur in the proximal convoluted tubule. When we have parathyroid hormone in high concentration, this will inhibit phosphate reabsorption from the nephron tubule into the blood, and it will increase calcium ion reabsorption from nephron tubule into the blood in the distal convoluted tubule. So what actually happen? I am writing a simple diagram here. For example, this is nephron, this is proximal convoluted tubule, and this is a distal convoluted tubule. So phosphate will not reabsorb. It will remain in the urine, but calcium ion will be reabsorbed and it will remain in the blood. So Pth will increase phosphate level, calcium level. Pth will increase calcium level in the blood in the kidney, but it will increase phosphate level in the urine. So phosphate remain in the urine, but calcium ion is reabsorbed to the blood. So this is what Pth separate phosphate from the calcium ion, and calcium ion level in the blood is increased. So now remember one point, if there is high concentration of phosphate in the urine, high phosphate concentration in urine, we checked and we checked the urine and we found that there is a high phosphate concentration in the urine. What will we think about PTH? PTH will released more by parathyroid gland or less. As we know that phosphate reabsorption is decreased by PTH. So if phosphate is not reabsorbed to the blood, it will remain in the urine. Thus, when we find high concentration of phosphate in the urine, it means that parathyroid hormone concentration is high in the body. Similarly, if we find low concentration of calcium in the urine, it means that the concentration of urine is low in the urine. The concentration of calcium is low in the urine because there is a presence of PTH in the body which has reabsorbed calcium in the distal convoluted tubule from nephronal tubule into the blood. Thus, that's why calcium level is low in the urine. Now, looks here at the activation of vitamin D. How activation of vitamin D occur? So, this is skin. When ultraviolet radiation fall on the skin, in the skin we have 7D cholesterol. When UV light fall on the skin, this 7D cholesterol is converted into cholecalciferol. This cholecalciferol is present in the blood, and in the blood this cholecalciferol go to the liver. In the liver we have hepatocytes, and an enzyme add hydroxyl group to the cholecalciferol and make it hydroxyl group attachment with the 25 number carbon of cholecalciferol, and as a result of this attachment of hydroxyl group we have a molecule with us which is known by 25 hydroxycholecalciferol. 25 hydroxycholecalciferol is formed. This 25 hydroxycholecalciferol go through blood to the kidney and it go to the proximal convoluted tubule. In the proximal convoluted tubule, we have an enzyme which is known as alpha-1 hydroxylase. Alpha-1 hydroxylase enzyme we have. This is alpha-1 hydroxylase enzyme present in the proximal convoluted tubule. This alpha-1 hydroxylase enzyme act upon 25 hydroxycholecalciferol in the proximal convoluted tubule and convert it into 125 dihydroxycholecalciferol. Actually, alpha-1 hydroxylase add another hydroxyl group to the carbon number 1 of 25 hydroxycholecalciferol. Thus, two hydroxyl group are present. We call it a dihydroxycholecalciferol. And we actually, as a result, we find 125 dihydroxycholecalciferol, and this is actually the active form of vitamin D. So in this way we activate vitamin D. Now we have activated vitamin D in the body. Now we will discuss action of vitamin D. So act upon GIT. Vitamin D act on GIT. Actually, from blood, when vitamin D go to GIT, this is blood vessel and this is GIT lumen, and this is a cell of GIT. Okay, when vitamin D come here, now we know that vitamin D is a type of vitamin which is lipid soluble, and lipid soluble mean that it can cross lipid membrane of the GIT cell. So the receptors which are present for the vitamin D in the GIT are present on the nucleus inside the cell, because vitamin D can easily cross the cell membrane. So this vitamin D act upon this receptor which are present on the surface of the nucleus. This vitamin D activate nucleus and then activate certain genes inside the nucleus. Then it causes the performance of a transcriptional process. When transcription occur, messenger RNA is formed. This messenger RNA from the nucleus go to the cytoplasm and it attach to ribosome, and cause the formation of a protein which is known as calbindin. This is a protein called as a calbindin. We can remember this name by calcium binding, calcium binding. Whenever we eat food and we have calcium in this food, this calcium is absorbed here. Calbindin go there and attach calcium ion to itself. This is calcium ion. Calcium ion is attached by calbindin to itself. This calbindin go on this side and cause the removal of or motion or movement of calcium ion into the blood from GIT. So what actually vitamin D do? Vitamin D activate the certain genes which cause transcription and then translation occur, and as a result proteins called as calbindins are produced. Calbindins what actually do? Calbindin cause the movement of calcium from the GIT cell into the blood. So this is the action of vitamin D. So we will say vitamin D increases calcium ion reabsorption in the GIT. So now we will talk about different problems that are related to the parathyroid hormone, different problem in which calcium level is increased and calcium level is decreased. So what is mean by hyperparathyroidism? Hyper mean high, parathyroid mean parathyroid hormone, related to parathyroid hormone. So parathyroidism mean increased concentration of parathyroid hormone, pathological increase. Pathological increase in parathyroid hormone is known as a hyperparathyroidism. So we have different types of hyperparathyroidism. One is primary, secondary, and tertiary parathyroidism. There are three types of parathyroidism, which are primary, secondary, and tertiary parathyroidism. Now first of all we will talk about primary hyperparathyroidism. Primary hyperparathyroidism, the first one, primary hyperparathyroidism. So primary, why it is called as a primary? This is called as a primary because here the problem is starting from parathyroid gland. Problem occur in parathyroid gland. Problem occurs in parathyroid gland. The basic problem is starting from parathyroid gland. That's why we call it as a primary hyperparathyroidism. Now this may be adenoma. Adenoma, what is adenoma? Adenoma occur in one cell of the gland or in a small part of the gland. This cell of parathyroid gland proliferate, and thus when they proliferate, a large number of cells are present and they form a large number of parathyroid hormone. When cells are more, it is clear that parathyroid hormone will also be more. So production of parathyroid hormone by adenoma cell do not depend upon calcium ion level blood. This is also important to be noted that it does not depend upon the level of calcium in the blood. If the level of calcium is low or high, it does not regulate the formation of adenoma because it is pathological condition. It is independent of everything. And another point to be noted that 80% primary hyperthyroidism occur by adenoma, but no metastasis occur, and this is benign. What actually happen? Proliferation of cells of parathyroid gland. 80% primary hyperthyroidism occur by the adenoma. In this case, proliferation of cells of a parathyroid gland occur and a large number of parathyroid hormone is produced. So most of the primary hyperthyroidism is contributed by adenoma, and it make 80%. And second thing, no metastasis occur. What is mean by metastasis? Metastasis mean, for example, if one organ when adenoma occur, then this adenoma cancer occur, this cancer spread to the other organ. This process is known as a metastasis. So as we will not say that when adenoma occur, because no metastasis is present in the adenoma. It is benign, and it is benign, it means that it is not cancerous, and proliferation of cell occur in this case. In the second form is hyperplasia. In this case also the proliferation of cells occur. Cells proliferate, and a large number of cells are produced, and these large number of cells are producing increased concentration of parathyroid hormone, and this make 15% of the primary hyperparathyroidism. It means that 15% parathyroidism is contributed by hyperplasia. The third form that is causing primary hyperparathyroidism is carcinoma. This carcinoma is very dangerous. It is malignant, and cell proliferation occur in this case. This is malignant. Malignant means that metastasis is also present, that this can spread from one organ to the other. For example, if this occur in the parathyroid hormone, this can spread to the surrounding organs, to the other organ of the body. So this is in this case what actually happen, that proliferation of the cells occur, and malignant and metastasis occur in. It is derived from epithelial cell. It is derived from epithelial cell, and this contribute only 5% of primary hyperthyroidism. This is very rare problem that causing a primary hyperparathyroidism. So carcinoma, in what actually happen carcinoma, that proliferation of cells occur. This is very dangerous. We will say this is malignant, and another thing that it is having the property of metastasis. Metastasis is what when cancer occur in one organ and it spread to the surrounding organ. This is known as metastasis, and carcinoma is derived from epithelial cell, and it contributes 5% of the primary hyperparathyroidism. Now let's talk about what is the result of primary hyperthyroidism with respect to different substances. So in the urine what will actually happen, when there will be increased parathyroid hormone, what will actually happen, there will be increased phosphate in the urine, increased hydroxy proline concentration in the urine, because what actually parathyroid hormone do, it remove phosphate, calcium and hydroxyproline from the bone. There will also increase cyclic AMP level in the urine, and there will also increase calcium ion in the urine. Now you will think this is the main point to be noted, that actually we know that when there is increased concentration of parathyroid hormone, what do, it increase reabsorption of calcium. But still we know that in high we know that when parathyroid hormone is high, still in the urine calcium ion is high. This has a mechanism. Let's think. In this case of hyperparathyroidism, there is so much high concentration of calcium in the blood, and this is filtered, and then so much high concentration of calcium is present in the urine, that if we increase reabsorption of the calcium from a nephron tubule into the blood by the help of parathyroid hormone, still this increased reabsorption cannot bring the calcium level to the normal, because there is very high concentration of the calcium in the urine. So increase in the concentration of the calcium in the blood and then into the urine is more as compared to increase in the reabsorption. As a result, there is a increase calcium ion in the urine. So this is calcium ion increase in the urine. Now in blood, what will actually occur in the blood? In blood also we know that phosphate will be decreased. Why? Because parathyroid hormone inhibit reabsorption of phosphate in the proximal convoluted tubule. Calcium ion concentration will also increase in the blood, because if it is present in high concentration in the urine, it is also present in high concentration in the blood, because reabsorption is also increased, and there will be high concentration of vitamin D. Okay, so this is the result of hyperparathyroidism. Okay, now we will discuss the action of a parathyroid hormone on the kidney. What happens when there is primary hyperthyroidism? What will happen in the kidney? In the kidney, the first problem that will occur is a nephrolithisis. What is nephrolithisis? Nephrolithisis mean kidney stone. Kidney stones will be formed. Okay, the second problem, that is nephrocalcinosis. Nephrocalcinosis mean deposition of calcium ion in the nephron. So what actually happen in the nephrocalcinosis? We know that this is nephron, and this is the last part of the nephron. In the first part of the nephron, we have a large amount of water. Whenever urinary filtrate is going from first part of the nephron toward the second part of the nephron, distal convoluted tubule, concentration of water decreases. Thus, whenever we have hyperparathyroidism, we will have high concentration of calcium in the urine. This calcium will deposit in the last part of the nephron. It will not deposit mostly often in the first part, because in the first part of the nephron we have a high concentration of water with the calcium. Thus its deposition usually do not occur mostly in the first part of the nephron. So calcium deposition will occur mostly in the last part of the nephron. So this calcium will deposit in the interstitium as well as at the tubule of the distal convoluted tubule. So this is the calcium deposition that is occurring here. This is calcium ion which is deposited here. Calcium ion that is being deposited here. This is known as nephrocalcinosis. So this is nephrocalcinosis. It is the deposition of calcium in the nephron, especially in the last part of the nephron. So what will actually happen in this case? Now we have ADH antidiuretic hormone. ADH will be unable to perform its function here. Why? Because calcium ion is accumulated so much that it cannot increase permeability of the distal convoluted tubule and collecting duct. So there will be no reabsorption of water, and urine will become very dilute, and this is called as a polyuria. So polyuria will occur in this case. First result is polyuria. Polyuria will occur because ADH will be unable to perform its activity. Normally we know that ADH increase permeability of the distal convoluted tubule and proximal convoluted tubule, but in this case it will not be able to perform its function because there is a lot of accumulation of calcium ion. So water reabsorption will not be occur, and there will be high concentration of water in the urine, and this will result in the dilute urine, which is known as a polyuria. Due to this dilute urine, most of the water will move out of the body, and we will have decreased concentration of water as a result at the end, and this is known as a dehydration. So in the body we will have problem of dehydration. Now this person has a deficiency of water in the blood, so this person will drink a lot of water. because he needs a lot of water, and this is known as a polydipsia. So this person has polyuria, dehydration, and polydipsia. This is just like a diabetes insipidus. What is diabetes insipidus? In diabetes insipidus, either ADH is not produced in the hypothalamus, which is known as a cranial diabetes insipidus, or either ADH is produced but there is a problem in the nephron where ADH cannot reabsorb water into the blood. This is known as a nephrogenic diabetes insipidus. So as we see that here PTH is produced, which ADH is produced, antidiuretic hormone, and which come to the distal and collecting duct. It try to perform its function, but it cannot perform its function. The problem is actually with the nephron. So we will say this is a nephrogenic diabetes insipidus. So we will say that primary hyperparathyroidism causes nephrogenic diabetes insipidus. Now we will discuss another point which is known as metastatic calcification. It is the accumulation of calcium in different medium. It is accumulation of calcium ion in alkaline medium. We know that we have discussed that accumulation of calcium occur in the alkaline medium. So any organ in the body which have alkaline medium, in this organ accumulation of calcium will occur, and these organs include stomach, interstitium, lungs, arterial walls of the arteries, and also kidney. In these organs, accumulation of calcium will be occurring. We will discuss each one. Let's first of all discuss lung. How calcium ion accumulate in the lung. How lungs are having a basic alkaline medium. Now simply we know that this is lung. This is, let's for example we have lung, simple diagram. Okay, now we know that the blood that is coming to the lung is having a large amount of carbon dioxide. So this is the blood coming to the lung having a large amount of carbon dioxide. And what actually happen in the lung? In the lung, carbon dioxide go from blood into the alveoli. So carbon dioxide is going out. This is carbon dioxide going out. Now we know that carbon dioxide is slightly acidic. Now here when carbon dioxide go to the lungs, okay, here in this part of the lungs, the last part of the lung we have no carbon dioxide, thus this become alkaline medium. This medium become alkaline and calcium deposition occur in this medium. Calcium deposition occur in this medium. Okay, so what is this? Calcium ion accumulation occur in alkaline medium because in the lung when carbon dioxide go from the bloods, this area become alkaline and thus calcium accumulation occur in the lungs. Another is stomach. So we know that in the stomach we have a special types of cell which are called as parietal cells. Parietal cell produce proton or hydrogen ion into the lumen of the stomach. But let's think this is a parietal cell and this is lumen of the stomach. We have a mechanism here, but I will shortly discuss. Whenever parietal cell secrete hydrogen ion into the stomach, it on the other hand also release bicarbonate ion into the interstitium. This bicarbonate ion is alkaline. So this bicarbonate ion make interstitium of the stomach alkaline, and thus here calcium accumulation occur. So parietal cell, this is parietal cell. On one hand, when it release proton into the stomach lumen, on the other hand it release bicarbonate ion into the interstitium of the lung, making it alkaline. Because bicarbonate ion is alkaline, so calcium accumulation occur in this alkaline medium of the stomach. This calcium accumulation also occur in the walls of the arteries and also occur in the kidney. In the kidney, mechanism of calcium accumulation is same as that we discuss in the stomach. On one side, cells secreted hydrogen ion to the lumen, and on the other side bicarbonate into the interstitium. Thus interstitium become alkaline and calcium accumulation occur, and this is called as a nephrocalcinosis, just we discussed before. Now here we have peptic ulcer. Calcium and also activate the cells of the stomach, which are parietal cells, that produce more hydrogen ion into the lumen of the stomach, and this may cause a peptic ulcer. Pancreatitis, it is also occurring due to a calcium ion deposition. Whenever there is a high concentration of deposition of calcium, then what actually happen, enzyme of the pancreas itself destroy the pancreas, and this causes pancreatitis. Now action on central nervous system. In the central nervous system, we know that during the depolarization, we have a cell of a central nervous system. Okay, this is a sodium channel. Okay, this is sodium channel, and this sodium channel, through this sodium channel, normally sodium ion move inside this cell during depolarization. Sodium ion is moving into the cell, but on this sodium ion we have accumulation of calcium ion, normally small amount, normal amount. But when there is accumulation of calcium in the CNS, this high concentration of calcium block this sodium channel, thus no depolarization occur, and the central nervous system become depressed, which cause lethargy and depression of central nervous system. So this is the high concentration of calcium ion in the central nervous system. Bones also become painful. Painful bone, because from bone a large amount of calcium ion is removed, because a large number of calcium ion is removed from the bone, and thus bone become painful. So this is what about primary hyperparathyroidism. Now we will talk about secondary hyperparathyroidism. So what is secondary hyperparathyroidism? In this case, there is too low concentration of calcium ion, and this low level of calcium ion then stimulate parathyroid gland, which produces high concentration of parathyroid hormone. Now we have different causes of secondary hyperparathyroidism. These causes include chronic renal failure. When chronic renal failure occur, this causes secondary hyperparathyroidism. This is the one cause of secondary hyperparathyroidism. The second cause of there is decreased intake of calcium. When we take little amount of calcium in the food, this can decrease calcium level in the body, in the blood, and we have a problem of hyperparathyroidism in the response. We have another cause, which is steatorrhea, and another we have decreased level of vitamin D, which decrease calcium level, and because anxiety, no reabsorption occur. So these are the various causes of secondary hyperparathyroidism. Now we have a tertiary hyperparathyroidism. Tertiary hyperparathyroidism occur whenever there is a very extreme secondary hyperparathyroidism. As a result of this extreme hyperparathyroidism, we have tertiary hyperparathyroidism. Now let's shortly talk about hypoparathyroidism. Hypoparathyroidism is mean what does it mean? That there is decreased PTH in blood because little amount of PTH is produced. It may be due to surgery of the thyroid, radical neck surgery. So what causes hypoparathyroidism? It may be due to surgery. Which type of surgery? Thyroidectomy, surgery of the thyroid. When sometime we have surgery of thyroid, parathyroid gland are also removed with this. And radical neck surgery, this is also cause of hypoparathyroidism. So these are the causes of hypoparathyroidism which are related to surgery. So the second main type of cause is congenital. It may be congenital. Now we know that third and fourth pharyngeal pouch make parathyroid gland as well as thymus. So whenever during development we have no development of third and fourth pharyngeal pouch, third and fourth pharyngeal pouch is not developed during embryology, during development, thus we have a problem of no development of parathyroid gland and thus hypoparathyroidism occur. Now we will talk about what are the different effects that occur in the body due to hypoparathyroidism. First of all, we have decreased calcium ion in blood. Blood level in the calcium ion decreases. Second, we have decreased bone reabsorption. Third, we have urine concentration of calcium in high amount. We have decreased parathyroid hormone in blood, which is actually hypoparathyroidism. We should not write here, but let's write. And thus we have increased phosphate in blood. You know all the mechanism when we have the concept of hyperparathyroidism. If you know about the hyperparathyroidism, you will know all about this. You should think about this. And if we have a very decreased concentration of the calcium in the central nervous system, then the sodium channel are very open. This will increase the central nervous system activity more than normal. Okay, so you should think about this. Mental state changes also occur in the state of mentality. Okay, and hallucination occur, frank psychosis occur. These are the different results of hypoparathyroidism. Change also occur in the ECG pattern, and in ECG pattern we have in prolongation of the QT interval. In hypoparathyroidism, in the ECG we have prolongation of QT interval, and we also have dental complication in the hypoparathyroidism. So this is all about what I discuss is about hypo and hyperparathyroidism. First I discuss parathyroid gland, parathyroid hormone, and problem that I discuss shortly about hyper and hyperparathyroidism. So I hope you will have understand. Best of luck. Thank you.